Shall we start the session now?
Yes, please.
A very good afternoon to all the respected dignitaries, coordinators, faculty members, and dear participants. On behalf of all ATAL Faculty Development Program, it gives me an immense pleasure and pride to welcome you all to this 12th session. It's indeed a great honor for us to have a distinguished industrial expert with us today. Our esteemed resource person for this session is Mr. Sabarinath Manivasaham, who is currently served as the head of EV driveline and thermal management system. He is a accomplished academician and industrial professional, holding an MTech in automotive engineering in Dixpelani and an MBA in industrial business from Pondicherry University, which perfectly blends deeply technical expertise with strong managerial insight. With an outstanding 19 years of rich industrial experience, Mr. Sabarinath has worked extensively in the designing and development of electrical vehicles as well as internal combustion engine vehicles. His professional contribution spans across small and long commercial vehicles, passenger cars, heavy commercial vehicles, and last mile mobility solutions include two-wheelers and three-wheelers. His vast experience in automotive R&D and futuristic mobility technologies makes him an ideal resource person for this ATAL FDP, providing a valuable industrial perspective that strongly aligned with academic research and teaching. We are confident that today's session will be highlighted, insightful, and beneficial for all the participant faculty members, helping bridge the gap between academic and industry. On behalf of all organizing committee, it's our privilege to warmly welcome Mr. Sabarinath Manivasaham to this 8th ATAL Faculty Development Program. And we sincerely thank him for sparing his valuable time to share his knowledge and experience with us. Once again, a warm welcome to you, sir, and we look forward to an enlightening and engaging session.
Okay. Thank you so much for that brief introduction. I'm really humbled and honored to be here in the forum where there are academic experts who are ready to collaborate with the industrial environment for the benefit of the society and the future. And thanks to PSNA College of Engineering and Technology for giving me this opportunity to have this good interaction with these academic environment. So without any further delay, can I go into my part of the presentation?
Yes, sir, we can start, sir.
Yes. I hope you can see my screen.
Yes, sir, it's visible, sir.
Okay. Thanks for that confirmation. Just give me a moment. Okay. So let's have this forum more interactive. So I request all the participants, if they have any questions, you can break me in between, interrupt me in between, so that this session can be more beneficial to you as well as to me. So today's topic regarding electrification in the automotive industry. The subject which was chosen for this ATAL AICT FDP program is very relevant to the current scenario, because the automotive industry, along with the other major industries, are seeing a major paradigm shift from the conventional way of thinking to new and alternate ways of development for the future generations to benefit. So one of that is being touched upon in this subject, that is the electric vehicle industry. And beyond electric vehicle industry, AI and ML being the drivers behind all this technology shift is also included in this subject, which makes this forum a more interactive and beneficial forum, I believe. So, my topic for today is from combustion to electrification. So, there are a lot of talks going on in the society, everyday news and technological discussions, where electrification is showing up as both a positive and negative impact on the society. But what really matters is the sustainability in the long run, which is why this alternate shift in the alternate technology is really required. Either it can be electrification or any other technology. So, in this next half an hour to 1 hour, we'll see how far the global trend is being captured, and how far it is going to be better in the future with the implementation of AI and ML. So I know I am actually in between a group of people who are very good in academics. So I'll not touch upon the academics too much in my presentation. But whatever data I'm going to show here is going to be a real-time and authenticated data from various reputed sources, which can be believed to be the future to some extent. So before I go into the subject, as you already got my introduction, I'll reintroduce on some of the points which are not touched upon. So I have totally of 19 plus years of experience, and right now I am working with an organization called T-Volt Electric Vehicles. It is actually a part of Murugappa Group. So for people who don't know Murugappa Group, they are the conglomerates of South India. They have a market capitalization of 75,000 crores, and they have businesses spread across multiple sectors, not only in automotives. They are spread across multiple sectors in FMCG, in power generation, in automotives, in part supplies, in food industry, etc. And this T-Volt electric vehicle is a venture which is started recently, which focuses on producing small commercial and light commercial vehicles. And before joining this organization, I was working with Renault Nissan. Most of you would have already known. So they are a reputed global passenger car makers in all segments. And Mahindra, our very own Indian automotive OEM company, and Ola Electric, who makes the revolution in the EV two-wheeler industry. So let me split this overall presentation into a few topics. So let me go one by one, not two steps at one time. So before we go into the detailed understanding of this transformation process from combustion to electrification, first, as we are all keen to know what electrification is going to do in the industry. So first of all, what is the need for EVs? So to explain that in a shorter way, the operational efficiency of an EV compared to its combustion engine counterpart can be compared with a parameter called well-to-wheel efficiency. So well-to-wheel is nothing but the process of extraction of the natural resources from where it begins until the extracted resources are converted and consumed completely. So this overall cyclic process is what we call as well-to-wheel. And this well-to-wheel can again be split into two, well-to-tank and tank-to-wheel. So well-to-tank is nothing but the natural resource extraction till it is ready for consumption. And tank-to-wheel is the point from where it is ready for consumption to the completion of the consumption process. So when it comes to an ICE engine, the well is nothing but the place where you extract the oil, and then it is sent to the refineries. It is split into different, segregated into different categories, and then the product is finally pushed to the market through dealers or corporates. And from there, the consumer, the user, basically we get this and we consume it to burn the fuel in our car, scooter, whatever it is. So this whole process, we call it as well to wheel. This well to wheel and tank to wheel, how are they different between different use cases of the vehicle? First, when we start with the regular engines, this regular engine actually consumes a lot of fuel, and most of you already know an engine efficiency, a diesel engine or a petrol engine efficiency is almost close to 30-35% max. With a very good technology and very good engine tuning, you can convert only 35% of your energy into a useful energy when you use a diesel or petrol engine. So that is the reason, that is one of the reason why the society, the governments are pushing the OEMs and the people to switch to an alternate technology where this efficiency can be improved. So there are a few technologies which are right now available with us. One is the advanced diesel engines. The advanced diesel engines are nothing but, if you can say from the Indian context, the BS6 engines. So Bharat Stage 6 is the latest emission norm being deployed in India. Same way we have Euro 6 emission norms across Europe, and all the countries have their own emission norms. So when it meets this emission norms, you can say the at least the dismissal of harmful gases on the society is limited to some level. But again, you're not working on the efficiency, you're only restricting the dismissal of products to the environment. On the other hand, if you have a new power, a battery, fuel cell, and hydrogen power cell data vehicle, these vehicles can do this on the opposite side. So you can, that the tank to wheel emissions are really, really low, because the tank, what it means for an EV is nothing but your power station where you charge your EVs. So from the place where you charge your EVs and then the place where you consume all the charge in your vehicle, you literally emit zero emissions. So where exactly this problem happens is well to wheel. So where do you get this power? It is generated somewhere in a thermal power plant or a nuclear power plant or somewhere else where it is already emitting a lot of harmful gases to the society. So this is how we try to understand how the efficiency of well to wheel and tank to wheel emissions are. To give you this in a precise number, this is from a trusted source. This precise number says your battery electric vehicles emits greenhouse gases as less as 35% compared to an IC engine vehicle. Of course, the data varies from country to country because of the usage of number of vehicles on road. But if you see, this 100% represents the emission of an IC engine. So if IC engine emits 100% of greenhouse gases, the equivalent amount of usage of an electric vehicle will emit only close to 35% of greenhouse gases. This is the least we are seeing. It may go up to 60 or 80 depending on the usage also. But this is one basic reason why the environment is important and the governments are shifting towards the environment just to make sure the greenhouse gas emissions are limited to certain levels. But when we say BEVs are, the battery electric vehicles are emitting only 35% of the greenhouse gases to the society, it is still the 35% is coming up from some of the other sources. What are those? This graph gives you a clear picture of that. This is a country-wise graph: Europe, US, China, and India, just to represent the major automotive users in the globe. And this is a comparison between the 2021 level and the projected 2030 levels. And this comparison is made for all the four countries. And the color of the graph indicates its respective points. So the dark blue here indicates the consumption of fuel. The light medium blue here indicates the production of fuel or electricity or whatever power source it is. The black here indicates the maintenance of the vehicle. And this gray color indicates the manufacture of the vehicle. And when it comes to EV, there is one more color called yellow, that is the battery manufacturing. Battery manufacturing and power electricity manufacturing are different, just for your information. So when you compare this, what you clearly see is in all the countries, current trend, 2021 trend, shows fuel consumption is the major source of greenhouse gas emission than any other reasons. Of course, the second is the production of fuel. You get this crude oil from some oil wells, you do the rigging, you take it to refineries, you convert it into petrol or diesel. So all these process also emits some greenhouse gases to the environment, but that is considerably low compared to the consumption part. The same trend is observed across the globe in the current trend. But when you see the battery electric vehicles, as I said earlier, the consumption of fuel is literally a zero emission part. What really emits the greenhouse gases to the society is just the production of electricity. This production of electricity is the key reason for emitting the greenhouse gases into the environment, which directly exists in the face of well to tank. Your tank to wheel is literally zero for an EV, but the well to tank is considerably high. And that too for countries like India and China, it is really, really high because of the production volume which we do within our country. And we are also supporting to the other countries for this generation. So what has to be done to reduce this? Because when we talk about alternate fuels or alternate technology for mobility, we have to find some point where this is really an alternate to safeguard the environment to the maximum level. So we still have to work on these fuel production or electricity production part to reduce the greenhouse gas emissions. So there are some few technological innovations happening around to make sure this discharge of greenhouse gases are also reduced by 2030. But still, the level of reduction is not much. We will still see some levels of discharge of greenhouse gases by 2030 also. And this is going to be a continuous process where beyond 2030, we may be able to reduce this greenhouse gas emission because of electricity production to a considerable level. So the push for an EV, when you talk about why EVs are needed in the society, this is just a survey data, again from a trusted source. This survey data shows how the existing EV owners are responding to their next vehicle. So this survey was taken with a sample size of people who are already owning an EV. They already drive a EV, either it is a scooter or a car or whatever, commercial vehicle, whatever it is. So these people who are users already, EV users, respond that they still buy the battery electric vehicle as their next vehicle. So they don't want to switch from EV to an engine vehicle or an EV to a hybrid vehicle. They want an EV again. So this trend clearly shows the demand of EVs across the people's intention to buy EVs are going to increase day by day. So as and when they start using the EVs, they get used to it and they don't want to go back to engine vehicles. So this describes why EV is being pushed to the society by the governments and for the benefit of environment. So next on the forecast on the automotive electrification. So what is going to be the market for EV in the upcoming days? Because 5 years ago, when EV were just in talks, only a few companies were producing electric vehicles. So they were just thinking that EVs are not going to be much and EVs are not going to make much change in the society. But now people, EVs have become a part and parcel of people's life. So what is going to be the future? This is a trend in the global market, which says the EVs volume are going to gradually increase across all categories of vehicles. So when I say EV, it's not just a car, it's not just a scooter. EVs are deployed in light commercial vehicles, it is in heavy commercial vehicles. It is now being deployed in tractors also. In Murugappa Group, we have a company which does the electric tractors. And EVs are now going to come in off-road vehicles also, like your this bulldozers, this boclanes, etc., etc. So the application of electrification is predominantly possible in across all the sectors. So the volume you see from 2024, the volume of EVs across the globe is going to increase 5 times of its current volume. So this is just in numbers. How is it going to be in terms of market share? Market share, when we say, uh, when you have when a market sells 100 vehicles, how many of that are petrol vehicles? How many are diesel? How many are EV? How many are hybrid? That is what we call it as market share. So this graph clearly shows two trends, two differentiated trends. The first is the data about the light duty electric vehicle, which includes your passenger cars, scooters, three-wheelers, your light commercial vehicles, everything. And heavy duty electric vehicles, particularly your trucks, your off-road vehicles, etc., etc. So this trend clearly says by 2030, the users of battery electric vehicles, that is a pure electric vehicles, are going to be up to 50% in China, because China is actually the leader in the current scenario for electric vehicle business, because they have too much of resources in terms of rare earth minerals, which is required for battery making, and they are good in making softwares which are mostly compatible with any kind of EVs. So in all these EV related technologies, China is ahead of any other country in the current scenario. And in China, the expected penetration of EV will be 50% by 2030 in light duty vehicle segments, which means every 100 vehicles which is sold in China will have at least 50 vehicles as EVs. The remaining will be include a mix of the combustion engine vehicles, your hybrid engine vehicles, etc. But this trend varies, of course, from country to country. When you say India, the penetration is still low. It is only up to 13%. The penetration level of EVs currently in 2026 is somewhere close to 3 to 4% across all the sectors. And when you take the light commercial sector, light commercial vehicle sector, which I am working on right now, the penetration is less than 2%. So the demand for EVs have to be created in the market so that this market share will increase drastically. That is what China has done so far. And when it comes to heavy duty electric vehicles, India stands less than 10%, somewhere close to 7%. But China again hits this chart with 35% plus for the market penetration. But how can this happen? Why people will prefer more EVs? Of course, if I am a customer by myself, I will not buy EV just because the government is asking me to buy EV. I'll buy an EV only if I have some benefit from EV. So when you buy an EV, what the EV companies usually tell you is the total cost of ownership is really low. But the down payment which you are going to put when you buy the vehicle will be relatively higher compared to that of an engine vehicle. For example, I buy a scooter for 1 lakh, EVs will cost me 1.3 or 1.4 lakh. It is going to be higher, but my fuel cost, my mechanical maintenance cost, everything will be eliminated here, which gives me the total cost of ownership in long run. Maybe in 5-10 years, the money which I spent to buy this EV would be relatively giving me returns in terms of fuel cost reduction. But even if this is the scenario, even if people currently are hesitant to buy EVs because of higher cost of EVs, they still want the EV cost to come down. So when the projection of 2030 says the market share of EV is going to increase, what are all the real drivers behind this increase? Mainly the battery prices. When you take an EV, the battery price is going to be 25 to 30%, or in some cases 40% of your total cost of the vehicle. For example, you are buying a scooter for 1 lakh rupee. The battery cost alone will be somewhere close to 30 to 40,000 rupees. So that is the main cost item which raises the down payment cost of an EV. So that is where the industries are working right now to reduce the prices of battery on the go in the next few years. But how this cost can reduce? This cost can be reduced only by two ways. One is an economical turnaround, which gives benefit of financial return. Second is technological innovation. So this technological innovation should be the key driver for EVs batteries in this current scenario, because the technology what we use right now for battery storage systems are not still 100% matured. We are still working on maturing and enhancing the battery as a product. So this trend shows from the current in the next 5-6 years, the battery prices are going to reduce, and this is going to be a big relief for all the industries, companies which makes electric vehicles, because their overall vehicle cost to the customer can be reduced. And as I said, technological innovation is one of the driver to reduce the battery price. The key technology which is dominating the EV batteries, high voltage batteries, are mainly the LFP batteries, lithium ferrophosphate. Lithium ferrophosphate batteries are a kind of lithium ion batteries, an improved version of lithium ion batteries, you can say. So that is more stable, that is more energy density positive, and that is more returnable in terms of cost and maintenance. So if I can tell you clearly, this LFP batteries or lithium ion batteries are the main game changers which evolutionized the EV industry in the last 3-4 years. Because before that, we used to have this lead acid batteries, which are not stable, which are very heavy. The energy density is very low. So it is not relatively practically suitable to adopt in an electric vehicle. When this lithium ion and lithium ferrophosphate batteries came into the implementation in vehicles, the whole EV pictures changed. So the evolution of new companies making various types of EVs came up, and still we are running successfully with the lithium based batteries. And the same lithium ferrophosphate batteries are going to be the game changer for the next 5 years also. But there are some alternate technologies being worked out, like sodium ion battery, and people are working on nickel-based batteries also. And there is something called a solid-state battery, which will be more stable. But right now, the maturity level of solid-state batteries they are not in 100% level to make it mass produced. So it is still in the research stage. So there are many technologies and batteries coming up, but still lithium ferrophosphate is going to drive the EV industry in terms of battery prices for the next 4 or 5 years at least. And also we are getting support from governments. This is data from the Indian government as of 2024. So the Indian government is pushing alternate power generation. As you know, in India, the consumption of power is already overshooting every year because of domestic usage, the household uses. So beyond the domestic usage, if you push more electric vehicles into the industry, then the demand of electricity will further increase. So the government also should have a backup in terms of increased power generation to a considerable level to match the requirement of EVs in addition to the domestic requirements. So in the past few years, you must have seen the government being promoting the solar panels in all the households, in all the industries, which gives us a clear indication as government is also working on supporting the EV environment with alternate power sources. So, solar power, wind power, and hydel power are three critical power generation sectors which are focused not just in India, across the globe to increase the power generation to meet the EV based requirement. So, when we see this whatever we saw so far is why EVs are needed and what is going to be the future of EVs in the next few years. So it is very evident that we are going to work on EVs, no doubt in that, for the next few years, and EVs are going to change the society to a different level in the next few years. Maybe in another 4 or 5 years, you will see more of EVs running in the road than the petrol or diesel engine vehicles. And you can see more of petrol bunks being shut down because of EV penetration, and more and more charging stations are being opened up. So all these are just predictions, but there are high possibilities that this will happen. So before we go and see what AI and ML are going to do with EVs, I will just give you a brief introduction about the differentiators of EVs. I hope most of you know this, being from the academic profession, but just giving you a brief heads up. So when I say EV differentiators, we are just going to talk about how the EVs are different from a typical IC engine vehicle in terms of architecture and critical components. So this is a typical electrical vehicle architecture. Your body, your wheels and tires, your axle, suspension, brake, steering, everything remains same as a regular IC engine vehicle. Only the power source and the traction source are going to be different, and the parts which are going to control this power source and traction force are going to be addition to it. So here what you see is a very broad level of EV architecture. So this traction battery pack, what you have here, can be considered as a replacement of your fuel tank in your IC engine vehicle. And your traction motor here can be considered as a replacement of your engine in your IC engine vehicle. And the other parts, what you see here, BMS, vehicle control unit, PDU, inverter, DC-DC converter, charger, etc., they are all allied parts which are going to control these two critical, this battery pack and traction motor, and they are going to drive the vehicle. They are going to use the motor and battery as per the requirement of the vehicle. So if I go one level detail on all the critical differentiated parts in EV. This is your high voltage battery, which is typically not seen in an IC engine vehicle. You will have a low voltage battery in an IC engine vehicle, but not the high voltage. But EVs will have high voltage because this is their main source of energy. And this is what I said will cost somewhere 30 to 40% of your electric vehicle cost. So this high voltage battery doesn't come as a battery alone. It comes along with something called a BMS, battery management system. BMS is a set of controller. It has a PCB circuit inside it. It's an electronic part, electronic controller, you can say. So this BMS is going to control the battery's usage. It is going to track the battery's performance. Sorry, somebody want to say something? Okay. So this battery management system is going to control and going to monitor your battery's health, your battery status, and your battery's criticality. And of course, when I say battery, this battery pack is actually made of regular cells, the batteries which we use for our the remotes or the wall clocks, whatever I say. That is a cylindrical battery. The same kind of battery, maybe with a different energy density, will be used here because the battery which we use here is an different electrolyte based battery, but the battery which we use in our domestic applications are of different electrolyte based. So, but typically what is used is a cell, a battery, whichever we see in our homes, something like that. And that will be packed in such a way that they are arranged within the modules placed inside the pack. And these set of cells will be packed into a single case, and this is called as a battery pack. And this battery pack is going to controlled by the BMS and the related circuits. The other critical part is your traction system. So in place of engines in internal combustion engine vehicle, you will have motor and MCU in addition to it. So motor, of course, it does the job of traction. It drives the axle, so the wheel moves on the road. But there is another part called motor control unit, MCU, which does the control and monitoring of your motor. Similar to a battery, how a battery has a BMS, your motor will have a MCU. Why these are important for the system? Why not they are used in IC engines? Is because these are electrically and electronically controlled parts, and there are many parts which are subject to heat losses. These heat losses are relatively much higher than the mechanical heat loss which we typically see in IC engines. So to avoid this heat losses, to reduce this heat losses and improve the efficiency of the system, these control units are really required. And just to give you a simple information, like when we talked about engine, we said the efficiency of an engine is only 30 to 35%. It can convert only 35% of energy into a useful energy. But in motors, the efficiency can be as high as 90 to 95%, which means your usage of motor is effectively done when you use it in electric vehicles. And these are the controllers. We saw the battery, we saw the traction system, and these are controllers which are typically used to control the overall operation of the EV, to give signals to different systems and make sure all the systems are running in the safe zone. So what are these controllers? One is MCU, I think we saw there. The other one is vehicle control unit. This vehicle control unit is a central controller which passes on the signal from one system to another or one controller to another to make sure all the systems, the traction system, the battery system, the other control systems are all in a single loop, so that each one system will not get affected because of the other system. All of them will do a give and take between themselves and make sure they are all working in their own safe zones. And that is managed by something called a vehicle control unit. That is a central controller. And we have an onboard charger. Onboard charger is required to charge the battery. So battery cannot be charged just when you plug in. There is some signal being given to the cells to take up the current and then start charging by itself, and that is done by the onboard charger. And DC-DC converter is nothing but when you have a high voltage battery, that is the traction battery with you, this high voltage battery cannot be used to run your low load parts in the vehicle. Sorry. Okay. So this DC-DC converter, this high voltage current cannot be used to run your headlamps. Let's say your headlamps or your starter motor or your power brakes, whatever it is. This high voltage need to be converted into a low voltage, and then it should be used in low voltage systems. And that is where this DC-DC plays a role. So if you see, most of the electric vehicles will not have this DC-DC converter because they will have one more small battery, LV battery, low voltage battery. But for vehicles which do not have a low voltage battery, this part is a mandatory part because this converts the voltage level from high voltage to low voltage as low as 12 volts and give to the entire system for its usage. And power distribution unit is again required to split the current from the battery to to be used for different parts, particularly the traction related parts. And to cover up all things, whatever parts we saw so far are the critical parts which are required to operate the vehicle itself. But when these are used to operate the vehicles, there are still chances that the heat loads are going to be very high. So the heat loads are high because the entire vehicle works on a lot of PCBs, a lot of electronic controllers, which by default emits a lot of heat. And these controllers have to be maintained in a safe temperature limit to make sure they are working properly. And if this is not done, then if any of these controllers fails, then the entire operation of the vehicle will be disrupted. And there are high chances the vehicle may not move also. So to make sure all these controllers and all the critical components are working within their safe limits, we should have something called a thermal management system. Of course, this exists in IC engines also. Even your IC engine will have a cooling jacket. Your IC engine will have a radiator, etc., etc. But the importance of thermal management system is relatively much higher for an EV compared to the IC engine because of the high heat loads which are generated by your controllers and your high voltage battery. And this thermal management system can be split according to your own convenience. It can be split, but typically, generally, this thermal management system is split into two major systems. One is traction cooling system. The other one is battery cooling system. The battery cooling system will take care of the cooling requirements of the battery alone because battery HEV high voltage battery is the topmost heat generation part in an EV. So it has to be taken care alone to make sure it is working fine. Otherwise, it may lead to some thermal disaster, which we usually see in our regular news, like the EVs are getting fired up, the EVs are exploding, etc., etc. So thermal management is a critical area where the batteries have to be maintained within its safe range. So a separate battery cooling system is always maintained in any typical EV you see. And the other one is traction cooling system. So apart from battery, whatever controllers, your motor, everything, whatever you have, need to be controlled separately. So these are all can be clubbed and controlled in a single system because the level of heat it dissipates is not as high as the battery. The level of heat it dissipates together, including all the parts, even that is much lower compared to that of what a battery dissipates. So with this introduction on this EV differentiators, how EV is different from a IC engine, we'll have a broad outlook on what is the participation of AIML so far in automotives, including electric vehicles, and how is it going to be in the future. So before we go into that detail, this is again another survey taken across the vehicle users. This vehicle users need not be an EV user, he can be any vehicle user. But when these users are asked about what are your important criteria to buy a EV, if you are a customer, what will motivate you to buy an EV? When this question was raised, most of the people gave the same answer what we all typically think: the range of the vehicle, the price of the vehicle, the safety of the vehicle, etc. etc. In this list, the need for advanced technology and the need for AI and ML penetration doesn't look critical. So most of the people said, for example, 35 respondents here said, for me, this connectivity and this advanced driver system are least critical. This black color means bottom five criteria. So they are all least bother to me. Only 9 or 8 people here said they are all important to me. We really bother about it. But this case, this trend remains same in Western countries. But when it comes to China, the maybe because of their recent advancement in software field, they are already ahead of thinking what is going to be the future of these softwares in electric vehicles. So the trend may be different, but this is the current scenario in the globe. And this is another data which clearly indicates from 10 years from now how these each of these points which were discussed in the previous page, how each of these points are going to gain importance in the next 10 years from now. So if you see this ADAS, Advanced Driver Assistance System, right now it is the ranking is only 10, which means it is not of much importance. But maybe in next 10 years, the ranking of this requirement by the customers will be in top 5. The same is the case with all the countries. So which in China, and it is very interesting to see that Chinese are going to think in the next 10 years that ADAS is mandatory for them. That is going to be the first priority, because by that time China will attain a matured state of EV production in all the areas, in software, in technology, battery technology, etc. So what will they seek next is automated system or advanced driver assistance system, which makes their drive more safe and more comfortable. So this trend is really positive to see that artificial intelligence and machine learning are going to be the key drivers for EV adoption in the future across the globe. So in the current uh, industrial market, how the AI and ML are being used? They are used in multiple areas. When we say AI and ML, they are, of course, they are software. They are software-based technology, which is going to be a soft background technology, which is going to drive the front end uh, technological advancements. But in what are the areas this A and ML are currently contributing to the automotive industry, particularly the EV, electric vehicle industry? The first is the battery management system. So battery management system, as I said, is very, very, very critical when it comes to an EV, and that is why the cost of battery is really, really high in an EV. So this battery management, why it is critical? Because the state of health of the batteries are really is a really important parameter to know across the usage. State of health is nothing but, for example, you are buying an EV today, and for the next 1 year, when you plug in your charger, let's say your charge is full and your vehicle gives you a range of, let's say, 100 kilometer per charge. Maybe in next 3 years or 5 years, when you full charge your battery, it may not give you 100 kilometers. This may reduce to 80 or 90 kilometers. This is what we call it as the state of health. So there will be a deterioration in the battery cells over a period of time because of regular cyclic usage of this battery. Usage, when we say, we give current and voltage on a regular basis, cyclic basis, to charge, right? So this will change your battery chemistry to some level, and over a period of time, it starts deteriorating in its performance. So this is actually not a problem with the IC engine vehicles, because in IC engine anyway you are going to use a fuel tank. You are going to fill the fuel. That's all. But when it comes to EVs, battery is very, very, very important. That is going to define your long-term usage as a customer. So monitoring your battery health and make sure your battery operates in the optimum level to improve its life, it's in a long run, is very, very important for battery management. So that is one area where AI and ML are right now used. So AI and ML are taking useful data from the battery on a real-time usage, and it learns and trains itself to make sure what can go wrong in the future and how to mitigate it, to make sure the state of health is gaining day by day. The second point for battery management system is optimizing the charging speed without damaging the battery. EV batteries, I believe most of you know already. So when you charge the battery, keep on charging the batteries on a regular basis, you are subjecting it to cyclic loads, and that will damage your cells to some level. And that is why people say, when you are, let's say you have 40-50% charge in your battery, don't do charging. Let it come down to 10-20% and then you do the charging. The reason is, let it be 40 to 100 or 20 to 100 or 10 to 100. For battery, everything means one cycle. So when you keep on charging regularly, that may damage the batteries after a period of time, and that will obviously reduce your charging speed also. This is anyway related to your state of health again. But the third issue is very, very critical. That is a thermal runaway issue. Thermal runaway is a phenomena where the battery will have a lot of cells. Let's say you have 100 plus or 100 or 200 cells in your battery pack. If one cell heats up significantly, that cell will pass on the heat to the next cell, and that will happen consequently. And end of the day, this transfer of heat to all the cells will cause a drastic hazardous failure to the battery, and that is what we see in real time as fire incidents happening in EV batteries. So this thermal runaway is a critical factor which all the EV industries, including us, are working on to make sure the batteries are safe from the thermal runaway part. And beyond the battery management system, the EVs can also be used for the range prediction and energy optimization. Range prediction, of course, is done even in the current scenario, but to give an accurate range to the customer who really wants to know, because sophistication increases day by day. So this is one of the sophistication that the customer want to know the accurate values on the range, which is controlled by the real-time behavior of the driver, driving habit, traffic, your weather condition, your road condition, and the vehicle load condition. And the other key driver where AIML helps is your autonomous driver assist system, which is called as ADAS. So ADAS, of course, is mainly to give you enhanced, safe, and comfortable ride for customer, and that is going to be the future. Many companies like Tesla, Google, Microsoft, they experimented a lot in this. Even when I was in Nissan, I was a part of the project which does this ADAS based vehicle development. But there are still a lot of challenges which are yet to be overcome to make sure you will have a driverless vehicle, you will have a completely autonomous vehicle to drive, to be driven in any condition. So AIML, with its power and technology, can bring that into reality, and that is where these AIML technologies are currently used by major companies across the globe to build their autonomous drive systems. And fourth is predictive maintenance and predictive diagnostics. These are key topics which are discussed across the after sales departments in the automotive industries. What are these basically? Uh, Suppose you are a customer, you buy a vehicle, you are facing some problem, some or the other problem. You take it to the service engineer. He will see and he will rectify it for you, and he will give back the vehicle. This is a troubleshooting of the problem after it happens. But now the industry, automotive industry, is working towards predictive maintenance and predictive diagnostics. So what we do is we try to predict the failure before even it happens. For example, if a customer is going to have a brake failure in the next 2 days, we should be able to predict that brake failure today itself, and we should inform or reach out to the customer and say, sir, there is going to be a problem. We will rectify it by so and so ways, if possible now or later. So this is predictive maintenance. So this predictive maintenance comes with a lot of data driven approach, and that is where AML comes to play, because AML can handle a huge data and give multiple solution options for any of the problems. And beyond the vehicle itself, the AML can help the EV infrastructure to some level. When I say EV infrastructure, basically the charging infrastructure for electric vehicles. So EVs not only AIML not only helps in building electric vehicles, it also builds the electric vehicle architecture infrastructure for the society. So smart charging and grid integration. These two are now the upcoming technological topics in electrical EV infrastructure area. So this smart charging and grid integration will give a connectivity between the customers and the grid operators, and it improves the cyclic usage of the charging stations and the grids between the customers and the uh, grid operators. So this is still in a nascent stage, and there are a lot of papers coming up on this topic. Maybe sooner or later, this will give a matured outcome for the EV charging infrastructure industry. So these are some of the examples which are already deployed in the automotive industry. Some are in EV environment. There are deployments in other industries also. So AIML has already played a major role in Tesla. In they name it as innovative BMS, innovative battery management system, where they are trying to do the predictive analysis of the battery status. The battery status can be a state of health. The battery status can be a state of charge, depth of discharge, the range, performance, whatever it may be. So, in multiple parameters, the innovative BMS is supporting the Tesla organization to do the predictive maintenance of their batteries. Same way, BYD is now the major EV player in the globe. BYD has overcome Tesla in the last few months to become number one EV company in the world. So BYD themselves have a lot of technology. They have something called a blade battery technology. All these are built based on AIML software platforms, and they have built something called a prevention of over discharge of batteries. This is actually related to your thermal runaway issue. So over discharge, prevention of over discharge is important to make sure your cells are operating at a very nominal temperature, and that will prevent your battery from being subjected to a heavy thermal load, and that will in turn prevent you from the thermal runaway scenario. So this is a patented technology by BYD, and this runs with the help of AIML learning and the implementation in their softwares. CATL is a battery manufacturing company in China. So they have implemented AIML technology into their factories to make sure the batteries are produced with utmost best quality with error-free production. So battery manufacturing is really a critical manufacturing. It is something critical like a semiconductor industry. So battery industry is too sensitive in terms of external environmental disturbances. So a manufacturing factory, a cell manufacturing factory has to be precisely designed and operated to make sure each and every battery and cell and battery pack that comes out of the factory are error free, and it is made in a very hygienic condition. So CATL uses this AML technology to implement smart factories to make sure this is done. This is one good example from Mercedes-Benz. Mercedes-Benz had tied up with Microsoft to make a cloud infrastructure called MO360. This is AIML based infrastructure which enable them to design the product till they produce the product in the factory. So Microsoft has given its cloud infrastructure, this Azure infrastructure, to Mercedes-Benz to make sure the process of production of vehicle is seamless, without any delay or without any stoppage, with high quality, with error-free, zero defect production. So whatever we saw so far are already existing AML technologies being used in the current industries. But in what ways AML can help us further? AAML still has a potential because see, for us, AAML is just a newcomer. So we don't know much about its capabilities and we don't know how much of capacity it really has. So we are still in the learning process of AAML, and maybe in the down the time we will be able to explore many more opportunities with AAML to make the industry more convenient, more effective. So these are just predictions on what is going to be the future of AAML in automotives. So first is ultra fast and battery safe charging. So the charging curves of the battery can be customized with the help of AAML in the near future. So re- with respect to the drive pattern, with respect to the charging pattern, the battery can adjust itself during the charge and discharge cycles. That will give a better state of health to the battery. So, for example, the battery, EV batteries, whichever comes now, may have a warranty of 3 years or 5 years or 7 years. Maybe if this battery safe charging and discharging is done, this warranty term in the near future can go up to, let's say, 10 years or 12 years. So the customer will be really secured in terms of battery life and performance. And AIs are also used now, are introduced, are trying to, the industries are trying to introduce this AI technology to design new battery chemistries. Because, like I said, lithium ion has been dominating this industry for quite some time. And that is what has changed the EV perception in the society. The same can happen if any other new technology pops up, and AI can assist the battery researchers in that area to discover new chemistries of battery, because rare earth minerals are a key challenge for all the OEMs to get in terms of supply, because China has the major supply chain management of rare earth minerals across the globe. So this situation can change in the future if alternate battery technologies comes up, and AI can assist in that. And of course, fully autonomous electric vehicle. This is nothing but the ADAS which we are talking about. So whatever the ADAS level we see in the vehicles right now are only up to 81 and 82. 82 is only in a limited premium cars only available. But what we are targeting is 85. 85 is the utmost autonomous vehicle, which means the vehicle is fully autonomous. You don't need a driver, don't need any guidance to the car. It takes care of itself. You just have to go in, come out, that's all. But this fully autonomous EVs are coming into reality only in the recent times because of the implementation of EV and AI and ML. We hope this will be taken care in the future years to get it done quickly. And there are some personal benefits. Being an EV customer, you will have some personalized experience if AIML will take care of your car. It can adapt the car to your habits and your requirements. And smarter EV ecosystems. Now, what is happening is the electric vehicles are charged from the grid. In future, even when I was in Ola Electric, there was a concept which was brought up by our CEO. So why can't the EV cars battery power up the home when there is a power cut? So this kind of reverse transaction of power usage is also being studied right now in the EV ecosystem, because uh, even when we were having the IC engines, it was only the engine running and you cannot connect the engine with your power grid directly to power up your house. But now it is a battery. So battery, why can't it power up the house? But this technology can be possible only if the batteries are made in such a way that it adapts to all these scenarios. So here, behind the battery, the technology which need to be adopted in the controllers or anywhere else should have this AIML intervention to make sure they are no, uh, going to give a reverse transaction to the society. And when we say AIML, of course, they're all softwares. They're all going to be run in the background to make sure the front end works better than before. That is what the role of AIML is. So when we talk about software, AIML has two roles. One is AIML can promote the software transformation itself. So whatever kind of software we use now can be completely transformed into a different form in the future, which may be simple, not much complex. The number of codes are very limited, and still it does a better job than what we are using right now. So that is one major role AI is going to give us. It is going to promote the software transformation across the industry. But in what means? Uh, Basically, we ask four questions. One is, what is the software that is to be developed? Second is, how is it going to be developed? Third, where it is going to be developed? And fourth is, where it is going to be adopted, implemented, how this software is going to be enabled. So, to all these questions, AIML already has an answer. So this Gen AI, which we are talking about in this current scenario, this Gen AI is going to help with your product management requirement. Your software development process is going to be transformed. Your capabilities of the software is going to increase, and your development value is going to increase. So the applications of the software is also going to increase, and your perception of the software is also going to transform. And this, of course, will happen through the regular software development process. So this is a typical software development process. I am not a software guy, but this is very this can be understood in terms of layman. So from requirements, after the requirement is set for a software, for example, a software need to be built for a let's say a provision store to bill, to make the bills and to record to monitor the what to say the stores, the stocks in the store. So if that is the requirement, then based on that requirement, a system architecture has to be made. And that system architecture should be converted into a software architecture in terms of software codes. You have to write code lines for the software. And then that will be converted into a component architecture. Once this preliminary set of actions are done, then we go into the development stage. We do the detailed development of the software. And this, after this development is done, we do a unit test. We just do a trial on how this software is working. But this trial will be done for individual modules one by one. And once this is successful, we integrate all the modules and do the integration test. This is the second level of trial. And once this is also done, then the whole system integration has to be deployed. Once it is deployed, then there will be a real-time test when it is deployed. So it will be open to the customers, real-time customers, and the real-time customers will do the acceptance test and confirm, yes, it is working fine. So in this whole software development process, AIML can accelerate this with the help of their back-end learnings and trainings, which it got from its inherent characteristic. So that is where the AIML acceleration can happen in terms of software development process. So as a whole, what we see here is AIML, of course, is a software. It is going to run in the back end. It is going to drive the front end processes. But how it is going to be used and where and all it can be deployed is what I tried to bring in today. So I believe I added some value, or I could be able to give you at least one piece of information which is useful for you in my session today. Thanks once again for this opportunity. Over to you, uh, people from PSNA, for queries and answers.
Thank you, sir.
Yeah.
Any queries from the audience? Uh, Participants, if you have any doubt regarding the session, you can ask now. Participants, those who are having any questions can clarify it now. If not, you can fill the feedback and the next session we will commence it shortly. We sincerely thank our esteemed resource person, Mr. Sabarinath Manivasagam, for sharing his valuable insights and rich industry experience with us. The session was truly informative and beneficial. We also thank all the participants for their active participation. Thank you for your time and support. Thank you, sir.
Thank you. Thank you, Team PSN, and thank you all for your patience. Thank you. See you. Bye-bye.
Participants, stay connected. We will start the next session within a short time.